Okay, so welcome to all of you. Today is the last chapter, that is the exact differential equation of the calculus second. Okay, so first we will see what do we mean by Bernoulli's equation. So what is the Bernoulli's equation? An equation of the form y prime is dy by dx. Okay, so you know that this is what y prime plus p of xy is equal to q of x. This is a linear differential equation. Only here what y to the power n is there. Only y to the power n is there. Okay, so all this is the same here. Only y to the power n is here. Okay, so what is n? N is any real number other than 0 and 1. Okay, so if n is equal to 0, then it will not a Bernoulli's equation. Okay, so if n is equal to 1, n is 0 or n is equal to 1, then this is a linear differential equation. If n is equal to 0 and n is equal to 1, then for n is equal to 1, this is not a linear differential. Yes, this is a linear differential equation. So if n is 0 or n is 1, then it will be the linear differential equation. Okay, so therefore your n is any real number other than 0 and 1. Note that n is any real number other than 0 and 1. Okay, this is the condition for this n. Okay, so an equation of the form y prime plus p of x y is equal to q of x into y to the power n. N is not any real number other than 0 and 1 is called a Bernoulli's equation. Okay, a differential equation of the form. So a differential equation of the form y prime plus p of x y plus q of x into y to the power n, where n is any real number other than 0 and 1 is called Bernoulli's equation. Okay, so these are the examples of the Bernoulli's equation. Y prime and see x y square there. Okay, so your p of x and q of x here are constant, they are 1. Okay, so therefore it is the Bernoulli. This is the Bernoulli's equation. This is also Bernoulli's equation. Y prime minus 1, y to the power 3 is there. Okay, but they note that there is no product y into y prime now here. Suppose if you are right here, y prime plus twice x y plus y is equal to x y cube. Suppose this is not a Bernoulli's equation. Okay, even though if you divide by this, but if you write this y square, okay, so then you can remove the y now here. So y you remove here, so this will what, then y, and this will what, the square. Okay, now this is the Bernoulli's equation. But if you not remove this what, so suppose like this is your y and this is suppose your y cube. Now at present this is not a Bernoulli's equation, because what, if you shift this here, so then your y get cancelled, then y, okay, but here there is no y now, so this is not out of form this, so that means what, this is not a Bernoulli's equation. So take the care of such type of the equations. Okay, so this is what 7x y twice y is there, y to the power minus 6 is there. Okay, so it is the Bernoulli's equation. Y to the power half is there. This is okay, no problem for this is a function of x. Don't bother about the x now. Okay, so e to the power 1 by x log x something sin x cos x tan x something all is okay now. This x to the power change, you can shift x to the power 7 to here and here. Okay, so that is also allowed to you. Okay, so I hope that you understand what do you mean by Bernoulli's equation, how to identify whether that function is Bernoulli's or not. Okay, so after that we have seen the homogeneous function. Homogeneous function. Okay, so a function f of x y is said to be homogeneous function of degree n. If f of tx ty is equal to t to the power n f of xy. Okay, suppose your f of xy, here I have written some examples of this homogeneous function. We'll find the degree of this one. So what about this one? If I put x is equal to tx, y is equal to ty, so what do we get then? F of tx ty is what? F of tx ty. Okay, so this is e raised to xy. If I put x as tx, y as ty, then your tt get cancelled, which is x1. So this is what then t to the power 0 f of xy. You get, so what? You get your function as it is, and there is no t, that means there is a t to the power 0. So this is a homogeneous function of degree 0. This is a homogeneous function of degree 0. Okay, what about this one then? Okay, so this is what? F of tx ty. F of tx ty is what? T raised to 4 x cube y. You are putting x as tx, so this is what? T cube, and this is t. So this is t raised to 4 minus 3. Again this is t raised to 4 x square y square. because t square x square t square y square is t raised to 4. You have to do this fastly. So this is what t square x square minus t square y square. From numerator you can take the t square common. From numerator t raised to 4 and this is. So whatever this, see here, this is what x cube y minus 3x square y square upon x square minus y square. This is your f of xy. This is your f of xy. So this is what t square f of xy. T square f of xy. So this is the homogeneous function of degree 2. This is the homogeneous function of degree. See here, this is 4, 4 upon 2. See, degree of each term is same now here. This is 4, and degree of each term is 2. So 4 minus 2 is 2. This is the homogeneous function of degree 2. See here, this is the degree 3 now. This is degree 3, this is degree 3. Okay. So all the term, each term have the degree same for the numerator and denominator. For numerator, see degree 4 here. Okay. So each term of the each term has degree same now. For the numerator, each term of the degree the degree of each term is same here for the denominator also. So degree of the numerator minus degree of the denominator. So 3 minus 3, this is 0 now. Okay. So degree of the numerator is what? 3. Degree of the denominator is what? 3. Okay. So this is also 3. Degree of each term must be the same. If degree of each term is not same, so don't say this is degree of the this. Degree of each term of the numerator is 3. Degree of each term of the denominator is also 3. So 3 minus 3 is 0. So degree of each term of the numerator is 4 and degree of each term of the denominator is 2. So therefore it is the homogeneous function of degree 4 minus 2, that is 2. Okay. Now homogeneous function means what? A function y is equal to f of xy is said to be homogeneous function if it is expressed in the form q of y by x or x by y. Y by x or x by y, doesn't matter. You are saying that x by y. So means what? If you put x is equal to tx and y is equal to ty, in your homogeneous differential equation, so your t should get cancelled. Okay. So you see, sir, this example. Y prime is equal to x, y prime is equal to y plus x e raised to minus y by x upon x. Now if you put here tx is what? Ty as t, this is tx, ty, tx. Now you see that your t gets cancelled now here. You can take t as numerator from this is y plus x e raised to minus y by x, okay, upon x, okay, t here. So see here. This t is removed. Okay. So if t is removed, then this is a homogeneous differential equation. So there is no degree of the homogeneous differential equation. So this is just a homogeneous equation. Okay. For homogeneous function there is degree. Okay. Okay. Suppose this is the equation x cube plus y cube y prime is equal to x square y. I can write this y prime is equal to what? X square upon x cube plus y cube. See the degree of the numerator and degree of the denominator, each term is same. If degree of the numerator and degree of the denominator, degree of each term of the numerator and degree of the each term of the denominator is same, then that is homogeneous. Okay. So this is a polynomial. This is also polynomial in xy. Degree of each term is same. So this is homogeneous differential equation. Okay. So now, if I consider this is what x square y prime is equal to y square plus xy minus x square. So I can write this y prime is equal to y square plus xy minus x square upon x square. See the degree of each term, this is 2, this is 2, this is 2. Degree of each term of the numerator and denominator is same. So this is homogeneous differential equation. Now, here the sec y by x e raised to y by x is there. Then you have to put x as tx, replace this is what? Y as ty, and see whether t is removed or not. Okay. So if you put here, see this is the example. Okay. So now this is y prime. So ty upon tx, t get cancelled here. Sec of ty upon tx, t get cancelled. So no t remains here. If you replace x as tx and y as ty, no t remains. So that means this is a homogeneous differential equation. So this is a homogeneous differential equation. This is homogeneous. This is homogeneous. This is homogeneous differential equation. Okay. So I hope that you understand the homogeneous differential equation. Now we'll see the exact differential equation now. Okay. So m dx plus n dy, m dx plus n dy is equal to 0. Is exact if and only if dou m by dou y is equal to dou L by dou X. This is the necessary and the sufficient condition. This is the necessary and sufficient condition that your differential equation is exact. Okay. So we'll see some examples of the exact differential equation. So suppose this is what 3x square y dx plus 4x cube dy is equal to 0. So I have to check whether this is exact or not. So this is your m and this is your n. Okay. So we differentiate this with respect to y and we differentiate this with respect to x. Okay. We have to differentiate partially. Means what? When we are differentiate this with respect to y, we have to keep your x is constant. So derivative of this is what is 3x square. Partial derivative with respect to y 3x square. Partial derivative with respect to x is here what? 12x square. 12x square. So 3x square is not same as 12x square. This is not exact. So this is not exact. Okay. Next, we'll do this example. 4x cube y cube plus 3x square dx plus 3x raised to 4 y square plus 6y square dy is equal to 0. So this is your m. So what? The coefficient of dx is there. Differentiate this with respect to y because this is coefficient of dx and this is the coefficient of dy. So for coefficient of dy, partial differentiation with respect to x and here partially. Okay. So we differentiate partial with respect to y now here. So this is what 12x cube y square. Okay. Partial derivative. Only this is y cube. We have to differentiate y cube. Derivative of y cube is what? 3y square. So 3. So this is 4 is there. So 4 into 3 is 12. Okay. For whatever here you have to differentiate this with respect to x now. Okay, so this is what derivative of 3x square. Your x is constant. So derivative of constant is 0. So derivative of constant is 0. Therefore derivative of 3x square partial derivative with respect to y is 0. Okay, partial derivative of 3x square with respect to y is 0. Okay, so here what we will differentiate this with respect to x now. So this is what 12x cube y square and 6y square is constant. So derivative is 0. So whether these two are same? Yes. So this differential equation is exact. Okay. So question may be asked by which of the following is not exact or which of the following is exact. Okay. So you have to check for first one. You have to check for second one. If it is not exact, right? So if dou m by dou y is not equal to dou n by dou x, then it will not exact. Check for first one. Check for second. Third one. Okay. Don't check for the fourth one. Fourth one will be your answer. If your condition is not satisfied for first three, so don't check for the last one. That will be your answer. Okay. So we'll do example of this. Suppose y square dx plus x dy is equal to 0. Is it exact? We have to differentiate this with respect to y. So this is twice y. We have to differentiate this with respect to what? X. So this is 1. So twice y is not same as x. So this is not exact. This is not exact. Okay. So y dx plus x dy is equal to 0. Okay. We have to differentiate this with respect to y. Derivative is 1. We have to differentiate this with respect to x. Derivative is 1. They are equal? Yes. So this is exact. This is exact. Okay. So y dx plus twice x dy is equal to 0. Okay. So derivative with respect to y is 1. Derivative with respect to x is 2. So this is not exact. This is not equal. So this is not exact. Okay. So y dx plus x square dy is equal to 0. Y dx, you have to differentiate this with respect to y. So this is 1. You have to differentiate this with respect to x. This is twice x. These two are not same. This is not exact. This is not exact. Okay. Okay. 3x square y square dx plus 6x square y dy is equal to 0. Okay. So suppose we'll check this. This is coefficient of dx. So we'll differentiate this y. So this is what derivative of y square is twice. So this is what 6x square y. Partial derivative is what. What about this one? We have to differentiate this with respect to x now. We have to differentiate this with respect to x. So we have to differentiate. This is what 12xy. So these are not same. This is not exact. This is not exact. So now we need to solve this one. Okay. So now suppose this is what 6x square y dx plus 4x cube y dy is equal to 0. Okay. Now we differentiate this with respect to y now. This is what 6x square. Now we differentiate this with respect to x now. So this is what 12x x square y. So these are not same. Not same. So this is not a exact. This is not exact. Okay. Okay. Suppose this is what 3y cos x plus 4x e raised to x plus twice x square e raised to x dx plus 3 sin x plus 3 dy is equal to 0. Okay. So this is the equation we have provided you. Now we differentiate this with respect to y now. So this is what 3 cos x. Derivative of y is 1 over. So here there is no term. This is purely function of x and derivative will be 0. So this is what 3 cos x partial derivative. Okay. Dou m by dou y is what? This. So what here you have to differentiate this with respect to x. So this is what 3 cos x. Okay. They are the same. They are the same. Very easy now. So this is what exact differential equation. We can say no. This is what comparing this with respect to m dx plus n dy. Then take m and then take n. Don't do this. Okay. Just we have to choose whether we have to identify whether this is the exact or not. Okay. So now this is the exact. Then how to solve this one? How to solve it? What is the solution of this exact equation? What? Just you have to integrate this. You have to integrate this. So you have to assume that this is what. Okay. Suppose this is not there. Okay. Suppose this is only 3y. This is 3y cos x suppose. Okay. So 3y cos x. Now this is what exact differential equation. Now how to solve this differential equation then? What? This is you have to integrate this what? Y constant. Here what? Term not containing x and this is the constant. How to integrate this? Y term not containing x. Okay. Term not containing x. Not containing x and is equal to c. Okay. This solution. Okay. Y constant. What is the integration of 3 cos x? So your 3y as it is. You have to integrate cos x. So derivative of cos x, integration of cos x is what? Just sin x. So the term not containing x, this term contains x. So you have to assume that this is 0. So plus 3y is equal to c. This is your solution. This is your solution. Okay. Okay. Suppose this is what 12x square y cube dx plus 21 x square y square dy is equal to 0. Okay. So we'll check whether it is exact. So we have to differentiate this with respect to y. So this is what is 56. Okay. 56 x square y square. Oh. 42. This is what? 42. 14 into 3. Okay. 42 x square y square. And here what? X square y square. Here we have to suppose this is the x cube then. Okay. So this is what okay. So this will not okay. This is not exact. This is not exact. Okay. Suppose this is we have given x cube y square minus 6x square y minus twice x minus 3 dx plus twice x raised to 4y minus twice x cube dy is equal to 0. Okay. We'll check if this is exact or not. Okay. differentiate this into y. So this is what 8x cube y minus 6x square minus 6x square. Okay. Now here we have to differentiate this with respect to x now. This is what 8x cube y minus 6x square minus 6x square. See, these are the both are the same. So this is exact. Okay. So if it is exact, if they will provide you this is the exact differential equation, then find its solution. Okay. So this is the this is what exact differential equation. Find its solution. Okay. They are saying that this is the exact differential equation. So no need to check this is whether dou n by dou y is same as dou n by dou x. Okay. So they are saying that this is exact. Okay. Now if it is exact, then we have want the solution of this differential equation. So how to find the solution of this? How to judge the solution of differential equation? Integrate this with respect to x now. Assuming that your y is constant. So this is what x raised to 4y square minus twice x cube y minus x square minus 3x. Okay. So your y is constant here. Derivative of 6x square. This is what 6x cube upon 3. So this is 2 here. 4x to the power 4 upon 4. 4 get cancelled. The term not containing x. Each term contains x here. Each term x contains x. So it is 0. Integration of this will be what? 0. So this is your C now. Okay. So this is your solution now. It is exact. Okay. Now suppose this is exact. Suppose y cube minus 1 e raised to x dx plus 3y square e raised to x plus 1 dy is equal to 0. Suppose this is exact differential equation and suppose y of 0 is equal to 0 is given to you. Y of 0 is equal to 0 or y of 0 is equal to 1, something is given to you. Okay. So now this is the exact differential equation. You want the solution. Solution will be what? Just you have to integrate this y constant. So this is what here y cube minus 1 is constant and integration of e raised to x is e raised to x. Here the term which do not contain x. So if you multiply, this is what 3y square e raised to x plus 3y square. Okay. So you multiply this. So this term contains x. So you have to assume that that is 0. And integration of 3y square is y cube. Okay. Is equal to c. So you have provided that x is equal to 0, y is 0. So x is equal to 0, y is 0. So what? So this is 0 minus 1 e raised to 0 plus 0 cube is equal to c. Okay. So e raised to 0 is 1. So this is minus 1. C is equal to minus 1 now. So c is equal to minus 1. This is your solution. Your solution is what? Your solution is what? Here you have to replace minus 1. Okay. It will be your solution. Okay. I hope that you understand how to find a solution of the exact differential equation. It's very easy now. Okay. Just you have to integrate with respect to y constant and the term not containing x for dy. For dy, the term not containing x, and you have to integrate with respect to y. You have to assume here y is constant. Okay. So in this way you can integrate this. Okay. Now this is a problem. Suppose m dx m xy dx plus x square minus y square dy is equal to 0. This is exact, and you want mxy. Okay. So here what? This is m. Okay. So dou m by dou y is equal to dou n by dou x is equal to dou n by dou x. So dou n by dou x is what? Dou n by dou x is what? Twice x. Now dou n by dou y is twice x. You have to integrate this with respect to y into y. So your m is what? Twice xy. So your m may be somewhere. So that is what? Twice xy. Okay. So now suppose your y dx plus nxy dy is equal to 0, and you want the nxy is exact. This is exact. Is exact. So it is exact. This what? Dou m by dou y is same as dou n by dou x. So dou m by dou y is what? 1. Dou m by dou y is 1, and dou n by dou x. So dou n by dou x. Dou n by dou x is what? Just integrate with respect to x. 1 thing. Okay. So this is your n now. Your n is x now. Your n is x. So check whether which option will be the correct. Okay. Suppose xy square dx is plus nxy dy is equal to 0. This is the exact, and you want n. So dou n by dou y is what? Twice xy is equal to what? Dou n by dou x. Integrate this in. This is what then? X square y is equal to n. Integration of twice x is x square, or integration of x twice xy. 2 is constant. Keep 2 as it is. The integration of x square is x square. Y will be the constant. It will be as it is. and integration of dou n by dou x is n, because this is the derivative. Integration of derivative is itself. So x square y is your answer. Okay. Now so here also you are given ln x y plus twice y sin x dx plus nxy plus nxy plus nxy dy is equal to 0. So you have to find nx now. Okay. So now what? Dou n by dou x. Dou n by dou x is dou m by dou y. You have to differentiate this with respect to y now. Okay. Log of xy is 1 upon xy into x now. Into x. Okay. Dou m by dou y. Derivative of xy is this. Okay. Plus 2 sin x. Plus 2 sin x. Dou m by dou y. Now you have to, this x and get cancelled. So this is what? 1 by y plus 2 sin x. Dou n by dou x. Okay. So now integrate this. This is what then? N is equal to x by y minus derivative of sin is this. Okay. Minus 2 cos x. X by y minus 2 cos x. This is your nxy. Okay. Easy. It is very easy now. Okay. Within a minute you can find this. Okay. Okay. Now this f of xy is said to be harmonic. Is said to be harmonic. Is said to be harmonic. If and only this is capital. Okay. So capital XX plus capital YY is equal to 0. Okay. That means double derivative of this, double derivative of this one. Okay. And harmonic conjugate is what? This G is harmonic conjugate, then Gx is equal to minus Fy, Gy is equal to Fx. Okay. So G is the harmonic conjugate such that if you differentiate Gx, you get a minus Fy. Take anything now, you can find a harmonic function. Okay. Now suppose your f of xy is equal to x square minus y square. Okay. What is fx? Fx is twice x. What is fxx? Is 2. What is fy? Is minus twice y. What is fyy? Minus 2. What is fxx plus fyy? Is 0. 2 minus 2 is 0. Okay. So this is a harmonic function. And you want to find a harmonic conjugate. So harmonic conjugate is what? Gx is equal to minus fy. What is fy? Your fy is what? Your fy is minus twice y. So this is twice y. Fy is what? So minus twice y. So minus y becomes plus. Now just integrate this. Your g is equal to what? Twice xy. So twice xy is the harmonic conjugate of this your x square minus y square. In this way you can find the harmonic conjugate of the any function. Okay. Now suppose this is your differential equation. 14x square y cube dx plus k x cube y square dy is equal to 0 is exact, then k is equal to what? Then k is equal to what? You have to find the value of k. Okay. So what is dou m by dou y? This is what 42. Okay. So 42 x square y square. Okay. What is dou n by dou x? You have to differentiate this. What? 3k x square y square. Okay. X square y square is there. That means 3k is equal to what? 42. So k is equal to what? 14. K is equal to 14. Okay. You got this. Suppose 4x plus ky dx plus 3x plus 4y dy is equal to 0. Suppose this is exact. You have to find the value of k. Okay. So this is what? Dou m by dou y. Dou m by dou y is k. Dou n by dou x is 3. Dou n by dou x is 3. Okay, you got the value of k. Automatically you got the value of 10 and k. Okay, so here you don't have to take the lot of efforts for this one. So I hope that you can do this one. Such type of the examples will be there. You have to take the care of the derivative now. Okay, so for exactness. Now there is the integrating factor now. Integrating factor. Integrating factor. Okay, suppose m dx plus n dy is equal to 0 is not exact. Is not exact and becomes exact if mu dx plus n mu dy is equal to 0 is exact. Exact means what? If you multiply by a function mu, right, so that your differential equation becomes exact, then mu is called integrating factor. Integrating factor. Okay. So that means if u is a, when we say that u is integrating factor, so suppose m dx plus n dy is equal to 0. This is the differential. This is not exact. Okay. So if this differential equation, if you multiply by a fixed constant, this is the function of x and y. U is the function of x and y. So now this is exact. Is exact. This is not exact, but this is exact. That means u is the integrating factor. U is the integrating factor. So now this is the exact. Then what is the integrating factor? 1 will be the integrating factor. 1 will be the integrating factor if the differential equation is exact. Okay. Okay. So note that this also. For integrating factor, you should remember this. Okay. So actually we have to find integrating factor for the simple problem. Suppose m dx plus n dy is equal to 0 is not exact. Not exact. Then integrating factor, suppose this is what f of x is equal to dou m by dou y minus dou n by dou x upon n. So this is what 1 by n. I can write this is what my minus nx. Okay. So this is a function of only x divided by n minus n divided by n minus n, and you are always differentiating n with respect to x and m with respect to y. So dou m by dou y minus dou n by dou x upon this. Okay. Then integrating factor is what? Then u of x. Okay. This is u of x because this is a function of only x now. Only x. So this is what? Plus or minus e raised to integral f of x dx. This is our integral. You may say this is p of x. You may this is whatever this q of x, something like this. This is the integrating factor. Okay. So if f of y is equal to 1 upon m. Okay. So dou n by dou x minus dou m by dou y. So here what? Minus m here. Okay. So minus m 1 upon m. Okay. This is a function of y. Then y is equal to plus or minus e raised to f of y dy. F of y dy is an integrating factor. So remember this. This is an integrating factor. Okay. So now suppose this equation is given twice x y cube minus twice x cube y cube minus 4xy square plus twice x dx plus 3x square y plus 4y dy is equal to 0. Well, we want only the integrating factor. Okay. So what is dou n by dou x? Okay. First we find dou n by dou y. What is dou n by dou y? 6xy square minus 6x cube y square minus 8xy. Okay. And dou n by dou x now. Dou n by dou x is what? 6xy 6xy. Okay. So this is not in the standard form. This is not our regular standard form. Okay. So here we have to take the, okay. This is not in the standard form, so we will not do this. Okay. Okay. This is our standard form now. Twice x y cube dx plus 3x square y square plus x square y cube plus 1 dy is equal to 0. You have to find an integrating factor. Okay. So now your dou m by dou y. Dou m by dou y is what? 6xy square. 6xy square. Your dou m by dou x is what? Dou m by dou x. Dou m by dou x is what? 6xy square. 6xy square. Plus twice x y cube. Twice x y cube. Okay. So what is your dou m by dou y? Dou m by dou y minus dou m by dou x. Dou m by dou x. So 6 so this is what? Minus twice x y cube. Minus twice x y cube. Okay. So if you write here, this is a c here. If you divide by this twice x y cube, twice x y cube. So this is what here? This is m. Okay. So 1 upon m. I will replace this dou n by dou x minus dou m by dou y. So this is what then? Twice x y cube upon twice x y cube. So this is 1. Okay. So this is what you are dividing by m and you are differentiating with respect to y. That means this is a function of y only. This is a function of y only. When we are dividing by m, function of y. When we are dividing by n, function of x should be there. Then y is equal to e raised to integral 1 dy. So that is integral 1 means what? This is y. E raised to y is an integrating factor. E raised to y is an integrating factor. You need only, don't write it plus or minus. So if there is an option there, plus or minus e raised to y, okay. So in general, we are taking the positive sign. Okay, we need only the integrating factor. So we don't need the solution of it. Okay. If you want a solution, just multiply this. Okay. So we do this. Okay. So 3xy plus 6y square dx plus twice x square plus 9xy dy is equal to 0. Suppose this is differential equation is given. We want only the integrating factor. Okay. So what is your dou m by dou y? Dou m by dou y. We have to differentiate in this y. So this is what? 3x plus 12y. 3x plus 12. What is your dou m by dou x? Dou m by dou x. So this is what? 4x. 4x plus 4y. 4x plus 4y. 4x plus 4y. We will check the equation once again. 3xy plus 6y square. Okay. Then twice x square plus 9xy. Okay, this is 9xy. 9xy. So this is what? 9xy. Okay. So now we do this what? Dou m by dou y minus dou m by dou x is what? So this is what? Just see this. This is what? Minus minus. Okay. So this is what? Minus x plus 3y. Minus x plus 3y. Now see here. You could take here. You cannot take any common here. You can take common here now. You can take common here. So if you take common here, which common you can take? 3x common suppose. Then this is what? 3y common you can take. So this is what? Then x plus twice y. Okay. So here what? X plus 3y is there. Okay. No. Okay. So that is what here. So this is not whole here. 1 upon m and 1 upon this. So you have to take another rule that there is there. So this is not a function of if you divide by m or divide by it will not here. That means what you have to think This is not hold here. This rule is not hold here. Okay. So this is not, that means what here. So this is f of x. That means e raised to integral f of x or e raised to integral f of y dy. Such type of the integrating factor is not there. Okay. So now suppose we have this equation. Okay. 5xy plus twice y plus 5 dx plus twice x dy. Okay. We'll find the integrating factor now. What is your dou m by dou y? Dou m by dou y. We'll try this. Okay. Whether this is applicable or not, that we'll see. So here what that rule, both the rules are not applicable here. Okay. In the last here what will dou m by dou y is what 5x plus 2. Your dou m by dou x, is 2. Okay. So dou m by dou y minus dou m by dou x. Take any subtraction. This is 5x. So if you divide by twice x, if you divide by this, so then it will be a function of this one. If you divide by this one, it will not a single variable function. So you divide by this 1 by n. So if 1 by okay, so dou m by dou y minus dou m by dou x. So this is what 5x upon twice x. So this is 5 by 2. This is only function of x. Constant is there, but you have to consider this is only a function of x. Then integrating factor is what? Y is equal to e raised to your function is what 5 by 2 dx. So this is what e raised to 5x by 2 is an integrating factor. Okay. We want only the integrating factor. Okay. Okay. So we'll take the next example. This example. Okay. Suppose this is what 6xy square plus twice y dx plus 12x square y plus 6x plus 3 dy is equal to 0. Suppose this is the equation. We want to find the integrating factor. So first we will see whether this rule is applicable. If rule is applicable, then we are saying that integrating factor is there. Okay. So dou m by dou y. Okay. So dou m by dou y. This is what 12xy plus 2. Okay. So here you can take y common here. Okay. For that we will do see here. 12 by dou x then. 12 by dou x what? 24xy plus 6. Okay. So I will do this dou m by dou y minus dou m by dou x. So this is what 12xy and this is what? We are writing minus now here. Okay. So then this is what? Minus 12xy minus 3. Minus 4. Minus 4. Okay. So I can take here minus 4 common. So what we get then? 3x plus 1. 3x plus 1. Okay. So if I see here, here I cannot take any common here. But here I can take the common twice y. If I take twice y common, then this is what? Twice y common. 12xy. Oh, this is 12xy. Okay. So this is, you have to take, this is 12xy. This is what? Minus 12xy minus 4. Minus 4. If I take minus 4 common, then this is what? 3xy plus 1. So here I can take twice y common. So this is what? Then 3xy plus 1. See 3xy plus 1 is here. 3x plus 1 y is here. That means we have to divide by m. We have to divide by m. So 1 upon m. Okay. Now you have to change the sign there. This is your dou m by dou y. If m is there, then minus dou m by dou y should be there. We will interchange the sign now. Dou m by dou x minus dou m by dou y. Now this become plus then. Okay. So 4 3xy plus 1 upon twice y. I have taken the common, that is 3xy plus 1. So this get cancelled. So this is what? 4 upon, this is what? 2 upon y. So this is f of y. Single function of y. That means rule is applicable. So e raised to integration 2 upon y is the integrating factor. So this is nothing what? E raised to 2 log y. So this is e raised to log y square. This means what? Y square. Your y square is integrating factor. Okay. So in this way you can find integrating factor. So I hope that you understand if the differential is exact, how to find its solution. If differential equation is not exact, then you have to find integrating factor. What do you mean by integrating factor? That also I told you. So what do you mean by integrating factor? A function function. If m dx is not m dx plus n dy is not, after multiplying it become exact. Okay, so then the factor is called integrating factor. Okay, so I hope that you understand all the things. Just do the simple problems like this. You don't need to solve this completely now. Okay, because what somewhere you have to use the by part form this one. Okay, so we are avoiding the solution of this one, but at least you can find the integrating factor of such non-exact differential equation. Okay, so here what you have to your derivative should be you should differentiate correctly. This is the differentiation partial with respect to y. This is the differentiation partial with respect to x. So carefully you have to do this one. Okay, so I hope that you understand the whole chapter here. We have revised the whole chapter here. Okay, so do all those things. Just try to solve some such type of the simple problems. Okay, I hope that you can do this one. Okay, so we'll stop here. Thank you.